Today we are going to see the normal and tangential coordinate system in curvilinear motion. Okay, suppose this is x-axis and this is y-axis. Consider particle moving along a curve. This is curve, and along this curve a particle is moving. So we will locate the particle at any point, suppose at this point. Okay, and we all know the velocity is always tangential to the path. Okay, so suppose particle is moving along this path and velocity will be always tangential to this path. Okay, so we will draw the tangent, we will draw the line which is in tangent direction, which will be tangential to this point. Okay, so this direction what we call tangential direction. As we know, velocity is always tangential to the path, so this is velocity vector v bar. Okay, now the direction which is perpendicular to the velocity vector, okay, and is approaching towards the center of curvature. Suppose this is center of curvature O, center of curvature of this curve. So this is curvature and the center is this one. So it is moving towards the center of curvature and perpendicular to the velocity vector. So this direction we call is the normal direction. This direction is normal direction. Okay, as this is center and this is the curvature, so this will be the radius. So we call this as a radius of curvature. So this direction is normal direction, this direction is tangential direction. So from O to P it is the radius of curvature, and we denote radius of curvature by rho. Okay, now if the motion of particle is described with these two motion, that is first motion is tangential direction, second direction is normal direction. If the motion of particle is described with these two direction, then this coordinate system is called normal and tangential coordinate system. We will now we will find the velocity and acceleration component. So the first is velocity component. Okay, now since the velocity is tangential to the path, okay, so the normal component must be 0. Normal component must be 0. And what will be the tangential component? Tangential component, we know it is a velocity itself. So these are the velocity component. Tangential component always 0, sorry, normal component always 0, and tangential component is velocity itself. Okay, now the second one, that is acceleration components. Okay, acceleration component, that is normal in acceleration in normal direction and acceleration in tangential direction. So the first is tangential component of acceleration, that is 80. Okay, so there is a derivation to calculate this tangential and normal component of acceleration, but we don't have derivation for our syllabus, so that I am going to write directly the formulas. Okay, so it is equal to dv by dt. So this we already know, acceleration is the derivative of velocity, so here we have the velocity. And the second is normal component of acceleration, that is an. So this formula we got from the derivation, that is normal acceleration is equal to v square by rho. So what is v? Velocity. And what is rho? Radius of curvature. Okay, So this is tangential component of acceleration, normal component of acceleration. So what is the how to get total acceleration? Total acceleration, that is A, is equal to under root at square plus n square. So this is the total acceleration. Suppose we need to find the direction of total acceleration, then how we will find this? So tan alpha is equal to at divided by an. So you will get the direction. Now we will solve the problem based on this normal and tangential coordinate system. So before solving the problem, to solve this problem we need a kinematic equation, but there is a little bit change in kinematic equation. So while using kinematic equations, for curvilinear motion of a particle, we need to always use the tangential acceleration. Means what? So we know the kinematic equations, v is equal to u plus at. So here acceleration we are going to use tangential acceleration, that is at. Same thing, and we know the another kinematic equation, that is v square is equal to u square plus 2as. So use a here, acceleration in tangential direction, and last one is the s is equal to ut plus 1/2 at square. So here also we are going to use acceleration as a 18, that is acceleration is tangential direction. Now we will solve the first problem. So I will read the first problem. A particle is traveling along a curved path of radius 300 meter with a speed of 108 km per hour and a tangential acceleration 4 meter per second square. Full stop. Determine total acceleration of the particle. Okay. So we will solve this problem. So first of all we will write the given data. So what is given in this? A particle is traveling along a curved path of radius 300 meter. So radius is given and we denote radius of curve, that is radius of curvature is by rho, that is 300 meter with a speed of 108 km per hour. So velocity is given 10 km. Speed means here we are going to take velocity, kilometer per hour, and a tangential acceleration. So tangential acceleration is given 4 meter per second square. Determine total acceleration of the particle. So we need to find acceleration, total acceleration A. So here tangential acceleration is given 4 meter per second square. Meter per second square it is given, and here it is kilometer per hour. So convert this kilometer per hour into meter per second. So velocity v is equal to 108 km per hour. So 1000 divided by 36. Solve this and you will get velocity v is equal to 30 meter per second. Okay. Now to find the total acceleration we need tangential acceleration plus normal acceleration we need. So tangential acceleration we have, that is 4 meter per second square. We need to find the normal acceleration. Okay, so how we will find the normal acceleration? We know normal acceleration a n. So what is the formula for normal acceleration? V square by rho. So v for velocity, v square is 30 square divided by rho is 300. So by solving this you will get normal acceleration is equal to 3 meter per second square. So we got normal acceleration and tangential acceleration. So we will find the total acceleration. So total acceleration A is equal to, what is the formula? AT square plus AN square, which is equal to 4 square plus 3 square. We will get the total acceleration 5 meter per second square. Now we will solve the second problem. The second problem is a car starts from rest on a circular curve of a radius 250 meter and accelerates at a constant tangential acceleration of 1.2 meter per second square. First off, determine the distance traveled and the time taken when magnitude of total acceleration is 1.5 meter per second square. So first of all, we will write given data. So what is given? A car starts from rest. So initial velocity is 0 on a circular curve of a radius 250 meter. So radius given, radius of curvature, that is 250 meter, and accelerates at a constant tangential acceleration of 1.2 meter per second. So tangential acceleration is given 1.2 meter per second square. Determine the distance traveled. We need to find the distance traveled and the time taken when magnitude of total acceleration is 1.5. So total acceleration is given 1.5 meter per second square is given. Now tangential component is given, total acceleration is given. So we will find first of all normal acceleration. We know total acceleration A is equal to under root AT square plus AN square. So A we have 1.5 under root AT 1.2 square plus AN square. So by solving this, you will get the value of acceleration, normal acceleration, that is 0.9 meter per second square. We also know normal acceleration, that is AN is equal to, what is the formula? V square by rho. V square by rho. Put the values. AN is 0.9 meter per second square. Velocity, so velocity we need to find. Here it is initial velocity is given. We need to find this velocity divided by rho, that is radius of curvature 250 meter, and by solving this you will get the velocity, that is velocity is equal to 15 meter per second. So according to the question, first thing we need to find, that is the distance traveled. So use the kinematic equation. We have the kinematic equation, V square is equal to U square plus 2ATS. V square is equal to U square plus 2AS. So we need to use here A is tangential acceleration, that is AT. So we have calculated, that is 15 square, which is 15 square is equal to U square, the initial velocity is 0 plus 2 tangential velocity 1.2 into S. We need to find the total distance. By solving this, we will get the S, which is equal to 93.75 meter. Next thing we need to calculate time taken to travel this distance. We have one more kinematic equation, that is V is equal to U plus AT. We have 15 is equal to initial velocity is 0, tangential acceleration is 1.2 into time. So solve this and you will get T is equal to 12.5 5 seconds. So this is the total distance travel, that is 93.75 meter, and time taken to travel this distance is 12.5 seconds.